I think it might be in the pocket. I might have actually been organized last time. Oh, I know. Star Christian, would you mind handing me the board? I think I need to put it on my iPad. Class. Kiddos! Oh no! Ready, set, go! You know how to solve it! Oh, sorry. Well. Thanks, Kate. I get this cast off today. You guys can wave goodbye as you walk out the door. We got 2 days. Because I need to get my stitches out. Then I'll get another cast off.
Yay! What color? I
don't know what color.
Do black. Make it purple.
I could do black, but then I feel like, I don't know.
It
Just go.
It goes with everything.
Do red so we can match.
Do red? No.
Match my Crocs.
Not a red.
Do purple.
Purple maybe, but then everyone's going to say I'm supporting LAB and then I'll get in trouble.
Oh. Or you do like the color purple. Do black and gold.
Black and gold? Then I just look weird. Anyway, here we go. It's such a struggle. This one was supposed to be like a very light teal, and I was excited about that, and then it shows dirt.
Clear. Clear cast.
Make it pink.
Gross.
Make it pink.
We're done. All right, so you guys are solving, right? My multitaskers aren't supposed to be talking unless you're working. I'm substituting in my comments.
Yes.
Actually, it kind of makes sense. Are we done? No? Okay, then tell me the steps so that I can follow them, but I'm freezing the screen so that you guys don't see my work, because then you'll just cheat and steal it and not think.
Yes.
She's backing me up. Good morning. What are you doing? How are you starting? Anti-deriving, right?
Yeah.
Anti-deriving. Look at you cheaters all over the place. Anti-deriving, right?
Yes.
And then you're doing a little bracket. And what are you doing with the little bracket? Putting it in on the bottom of. You put a little bracket after your antiderivative, remember? F of B minus F of A is really the antiderivative from A to B. So 0 is the bottom bound, pi is the upper bound. Question, who do I plug in first?
Upper.
That's upper one. It's on. So not true. Fail.
It's called sharing.
Sharing is scary?
No, sharing food. Thank you.
How's it look?
Great.
Now what do we have to do? Unit circle. Keep going. Come on, we know unit circle is important. Who is secant? No one likes secant. He's 1 over who? Cosine. Life just got a little bit better. How's it look now? Pi over 3 in the unit circle. Where's that guy at? First quadrant. That's true. Where in the first quadrant? Because remember, pi, this is how I reminded this year's class of it. I don't know if it actually helped. They all said they hadn't eaten one before. I said that pi, whenever you think of pi, it's not like pizza pie, that's totally round. Instead, pi is a calzone. Oh, because it's a half circle. And then if you have 1/3 pi, it's 1/3 of a calzone. Guys, doesn't that look like 1/3 of a calzone? Right? Awesome. An entire pre-cal class was like, what is a calzone?
Parts and the rest.
They're doing something wrong with their life.
So 1/3 of a calzone, aka 1/3 of pi, is right there, right? Nice. Anyway, in case that helps. If you haven't had a calzone, your homework is to eat one. It's like a Hot Pocket, but bigger and better.
Yeah.
And rounded. How pockets they are rounded.
Alright, let's do this thing. Right here, right here. Blaze. What for calzones? What? I know, right? I know. That's so good.
Wait, pause! Who's cosine? We're all distracted. I know, it's my fault. Cosine is the x, so the x is going to be over a little. 1/2. Reciprocal. 2. We get pi squared over 9 minus 2 plus, what's cosine of 0? 1. So therefore, final answer is pi squared over 9 minus 1. Okay, so what's
Oh, it's like biology.
Oh, I think that's really good.
Blaze, it's like, it's all by the same company, I think, as the habit. So Blaze and habit are like always together.
I've never seen Blaze.
Really? I don't know. The first one is knocking on it.
Underneath the food part.
All the Bacchanal also
And then
has a paradise.
Blaze.
Like has the Blaze, Panera, Habit, and Chipotle.
Oh, it's all in the same place?
Yeah.
Okay. Questions? Why didn't I keep going? Because I didn't feel like it, and there's a pi, and we're not going to approximate with decimals. All right. Now what? Kind of the same thing, but what's different?
Absolute value.
You. Right?
Yeah.
Who likes that? That's a new example. Aaron, this top one, I can't get unless you want to take a picture of it. All right, thanks, bud. Okay, what changes with the absolute value? Do not start solving yet. Do not start solving yet. Write down the problem. I have a graph for a reason. Ella.
Sorry, can you scroll up a little bit, please?
Is that enough?
Yeah.
That's good? Okay. Why do I have a graph? Because I need to show you something. Question, kiddos. All the way back in Algebra 1, maybe didn't learn so well there. In Algebra 2, what happens on a graph graphically when there are absolute values around the whole function? What's positive, the x's or the y's?
Y.
The y's are positive because the entire function is a y. But wait a minute, look at the graph of, hold on, who is this guy? This is the graph of e to the x minus 1. Do you guys see the e to the x shifted down 1?
Yes.
Right? Okay. So this is the graph of e to the x minus 1. I'm allowed to have the positive y's, right? They're fine. But who am I not allowed to have? So how do I make the negative y's into positive y's? Absolute value, but that's algebraically. How do you do it on a graph? Flip it. So therefore, what is this a graph of now?
Absolute value.
Exactly. Now hold on. Do we know how to anti-derive just the inside part?
Yeah.
Yes. But the problem is this just the inside part?
No.
No. Struggle. What changed? What changed from what, I know it's super exciting, try to hold in your enthusiasm. What changed from what we had, focus, 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 from what we had to now what we have?
Oh, it's the same exact thing. Oh, but it's positive instead of negative.
Uh-oh. So wait, how do we do that? So hold on, absolute value, did part of the graph stay the same and part of the graph flip?
Yeah.
Oh my goodness, that's a thing with absolute value, right?
No.
Positives stay the same and negatives flip. So the gray was what just plain old e to the x minus 1 is. The yellow is with the absolute value. So hold on. Struggle. What x value marks the switch from flipping to staying the same?
0.
What's so special about 0?
Nothing.
In this example, what's so special about 0? So special, in fact, I'm going to actually split up my integral into 2 pieces. Something before 0 and something after 0. But why am I doing that? What was so special about 0 that made it mark the spot of the flip? It will be a sharp point of the new one. Yeah. Question. Okay, hold on. What if I give you another example? What if I was to give you the absolute value of Hamlet needs to be gone or else I steal it. Math does need to be out and talking about randomness with Hamlet waving in the air needs to stop. So, what if I was to give you the absolute value of something like,
Do that.
let's do x minus 3 cubed. So something like that. X minus 3 cubed. Now, don't necessarily write it unless you need to see this in a little bit more detail. But x minus 3 cubed absolute value. Question, who is the parent function of this graph?
The S curve.
Yeah, it's this graph, right? But he's not there because what does the minus 3 do? Shift it, not down, it's on the inside.
Oh, to the right.
To the right.
Oh, to the
To
right.
the right, remember?
Right.
Ryan was right. The negative, it's opposite what we think. That was a long time ago. So we go a 1, and we go a 2, and we go a 3, and then we have our little swoopy swoop. Now, hold on. I'm swoopy swooping the old curve. The curve, I should say, within the absolute value. It would just be a swoopy swoop right here, right?
Yeah.
A question, what does the absolute value change?
The bottom.
It becomes a triangle.
This stays the same. What happens to the bottom part?
It flips up.
It's going to flip.
So they just depend.
Oh, that's weird. So what's going to happen with the area? Well, okay, hold on. The area before was sum over and sum under, right? Remember, over is positive area, under is negative area. That kind of looks like 0 area if we made it symmetric. What's going to happen now that the absolute value is in there? It's going to double instead of canceling out. How would I split up the integral in that example? If I were to say, hey, this is really just an integration problem from, let's go, I don't know, 1 to 5 maybe? dx. You guys saw me split up the integral over here at 0, right? Oops, I don't know where I was going. I split it up at 0. Where am I going to split it up in this example? Why?
Because that's what it changes.
That's where it changes, true. But what is similar between the
What's
0
the
on the
0?
right hand and the 3 on the left hand?
It's zeros.
They're both
Zero.
zeros of the function, which means
Wow.
they're both x-intercepts. They're both x-intercepts. So I'm going to split up absolute values at intercepts. Why am I telling you this? Because kiddos, do we really want to have to make these graphs every time?
No.
No, that's going to take forever. But what could we do with the function in order to find that split up point without actually having a graph? Exactly. We can set everything equal to 0. Does that make sense? Everything meaning the inside of the absolute value. So let me go ahead and show the work how we didn't have to have a graph of this absolute value we do. There we go. This is where we're going to go. But first of all, how could we find the split up point? Split up. Can I say split at e to the x minus 1 equals 0. We don't need a graph. Now, graphs help us, especially when we're first trying to figure out the idea of absolute value and how does it change the area and what are we supposed to do. So I'm starting with graphs, but I don't want you guys to have to do graphs every time because, frankly, we're not so good at it. Some of us are better than others. We've been learning it for 3 years now, but that's okay. Anyway, coming back. Solving, solving, solving. E to the x is equal to 1. Oh my goodness, how do we solve for x when there's an e? Nice. ln of one side, ln of the other side. That's an ln, by the way. We end up with x is equal to, who's ln of 1?
0.
So what's my split up point? 0. Did I need the graph? Not really, but it does help you hopefully reinforce the idea of what's going on. Does that make sense? Okay, let me go ahead and get rid of this extra example. He was good for illustration's sake, but he's kind of going to make everything messy and complicated. Let's just go back to the original problem we were doing. We need to solve. Now hold on. We split up the integral. That was the first thing I needed you guys to see with absolute value. We're going to split up the integral. Our goal is to be able to solve, once again, an integral with an absolute value. Okay, what's going to go inside the integral? Do we want absolute value anymore? No. Which side? The left side or the right side is going to stay the same?
Left side is going to have absolute value.
left side needs to switch, right? The right side stays the same. So let's just go ahead and say whatever, e to the x minus 1 is sufficient for the right side. Does that make sense? Whether there's absolute value bars or not, the right side stays the same. Whether there's absolute value bars or not, the right side stays. Oh my goodness. Didn't do my speaking exercises this morning. Just kidding. How am I going to accommodate for the change that occurs without using an absolute value bar because he makes it so I can't solve the integral? Oh, I can put a negative? What does a negative do to a quantity? It flips it, right? And if the quantity was negative to begin with, and negative times a negative is going to make it what? A positive. And negative times a negative is a positive. So all we have to do, I know, struggle. There we go. All we have to do is take what was there, e to the x minus 1, and put a negative. Now, there is another way to shortcut the process, where you don't even actually need to realize which side is flipping or not. And the other way to shortcut the process is, instead of figuring out who stays the same and who switches, we could have also done something, we changed the color to green. We could have also, instead of doing any of that, we could have just said, hey, whoever the final answer is, you better be positive, and whoever this final answer is better be positive also. Now pause and be careful. I'm not just haphazardly, willy-nilly pulling out the absolute values. I have to split up at the 0. I have to split up at the 0 because making this absolute value and this absolute value is different than making the whole thing absolute value, okay? We have to split up at the 0, but we could shortcut the process and say, I don't care who stays the same or who flips. I'm just going to find both of them separately and then just make them both positive and add them together. That's a shortcut. Kiddos, here's the sad part. Lo siento, but we still have to solve. How do we solve? Antiderivative. Okay. Yeah, he's an easy one, right? E to the x comes from, he's the derivative of e to the x. 1 is the derivative of x. And this little guy is going to go from 0 to 1, yeah? Plus, this side, we already know the antiderivative, e to the x minus x, except the whole thing is negative. Can I just switch both signs? Is that okay? I'm just switching both signs, multiplying in by the negative. This guy is going to be from negative 1 to 0. How are we doing? Now, what do we have to do? We just got to plug in numbers. Now it's all just a numbers game. But we got to plug in carefully, right? So, for the first one, let me go ahead and zoom in because it's getting kind of small, right? All right. How much space do we have? That's about it. I'm going to start writing smaller as a result. Plugging in 0. Negative e to the 0 plus 0. That's f of b. Oh, not f plus x. I wrote the wrong thing. That's f of b, right? Plugging in the top number. Now I need to do f of b minus f of a. Who am I plugging in now? Negative 1. Negative e to the negative 1. Plus negative 1 is minus 1. Plus. Okay, do you see my f of b minus f of a for the left-hand one? Okay. What do I have to do for the right-hand one? Same thing, yeah? But now, my b is 1, yeah? F of b minus f of a, e to the 0, minus 0. Guys, I realize some of you are like, this is so tedious. Yes, but if you're going to do all this work, why not get it right? True? True. So take your time. Do it carefully. Get it right. If you're going to do work, you may as well do it right. Hey, that's a life lesson. So now we go ahead and say, what are all the e to the zeros? Yeah, anything to the 0 is just going to be a 1, right? That's just going to be a 1. We can distribute our negatives if that helps a little bit. Distribute our negatives. Well, that's just 0. Cross out the zeros, they're gone. E to the negative 1. Who's E the same thing as? E is 1 over E. All right, let's put it together. What do we got? We have 1 plus 1 minus 1 plus 1.
Where's the negative one?
Oh, I didn't write my negative. Oh, struggle. That was very dangerous. See? Thanks, guys, for doing your work right.
And isn't the last one
Nope, because the last one... Oh, the last one. I was looking at the middle one. Struggle. I was having too much fun with my ones. I didn't pay attention to my signs. So I have negative 1 plus 1, right? Okay, so those two cancel. And then I have negative 1, negative 1. So negative 2? Ah, because it was minus for f of b minus f of a, and the negative had to come into the e. You see it? I switched it right here. I brought in my negative. I have negative 2. Hold on, who's left? So we got rid of those guys. Plus 1 over e plus e. That's gross. Whatever, stick it to the man. Dun, 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 dun. Wait, this has to be a positive number. It's not a positive number, is it? Do you remember who e is? 2.7 is 828? 818? Something or other. 2.7, 1828? Anyway. Oh, 1828. Struggle. So that's 2.7-ish, and that's 1/2-ish, which is definitely going to be bigger than negative 2. So yeah, it's a positive. Don't worry, we did it right. But kiddos, if you ever take the absolute value, or the integral of the absolute value, and it's negative, did you do it right? No, because it has to be a positive. It has to be a positive. All right. Are we talking because we're bored? Here we go. Keep going. Must go faster so that you don't get bored. All right. Handling integration with absolute value functions. I decided since it's a tricky process, we better just write it down, okay? So we're going to split up the integral using the y-intercept setting, y equal to 0. And remember, who's y? Yeah, the entire thing inside the absolute value, right? Not the entire integrand. Maybe there's something else being added or subtracted outside the absolute value. But when we're taking the integral of the absolute value of y, let's not do y, that's nasty notation, of f of x dx from an a to a b, we have to split up. How? Set equal to 0. If you guys want the notation to match, you could change this to f of x equals 0 instead of y equals 0. You guys know it's the same thing, right? Yeah, Ange, what's up? Alright, don't get lost. And then number 2, find the sum of the absolute values of the resulting. Wait a minute, I'm not telling you to graph it and visualize it and show the flipping this. No, I'm just saying, you know what, let's use that shortcut. As long as you split it up, if we take the absolute value of the integral, meaning integrate first, do f of b minus f of a first, then make absolute value, then make it absolute value. It'll end up okay. All right, kiddos. I'll give you an example to practice with. Who's getting text messages? Stop. Put on Do Not Disturb. Or get the vibration off. Doesn't Do Not Disturb get the vibration off? I think it does. But hopefully everything's okay. It's not letting me know. What are we going to do, kiddos, on the example? there's a step right above. Oh, hold on, wait a minute. These steps are kind of important. You're welcome. Dun, 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 dun.
Yes.
Dang it. Ah.
Should be updated? They are.
They are, except for yesterday.
Okay, so what is the test gonna be on?
Not all of them. Sorry, all of them starting. You guys, hold on, help me. It was number 30, right?
Yeah.
Starting number 30.
Well, like to like 39?
Yeah. We're on
Oh,
30.
what's this one?
38.
To 40.
Oh, I don't think 37 is on there.
Yeah, I covered them yesterday.
Oh.
Thank you very much. As long as they're out of the I'll get them all the way through the ones on the quiz.
There are any notes on the
Alright, cool kids. We need to split, right? Split at. Whenever you see absolute values, I need you guys to think of the splits. Banana split, doing the splits, I don't care, but you're splitting, okay? Absolute values split at who? The zeros. X squared minus 1 equals 0 at x equals. How many zeros are there? 2. Struggle, which means we have to split this up how many times?
3.
So we go from -3 to -1 of x squared minus 1. Then we need to go from -1 to who? To 1 of x squared minus 1. Then we need to go from 1 to
Is that not a horizontal?
3 of x squared minus 1. Is what not a horizontal?
That x squared minus 1.
I mean, you could graph it pretty quickly since he's an easy one. He goes down 1 and he's x squared. So you could go ahead and maybe flip it. Like this is, some of these guys you could graphically do maybe pretty quickly. See? So what we're trying to find is this area, which was mostly what it was before, but not entirely, right? Because before it had that and it had that, but this one was flipped. But once again, I'm trying to say you don't need the graph. You don't need the graph. Okay. How do we solve? Carefully. How do we solve? Lots of f of b's minus f of a's. Right? Oh, wait. We didn't finish our steps.
Oh, absolutely.
We need to say, hey, split it up, but since we're not thinking about the graph, we're just going to say take each one separately, figure out who they are, and then make them each positive and add them all together. So you split, and then you absolute value. Then you gotta solve if it's a by hand one. Guys, if it's not a by hand one, can we plug an absolute value in our calculator?
Yes.
Yeah, so we could do that whole thing. This is why it wouldn't be a calculator problem. Why would you be doing it by hand? You wouldn't. You would just plug and chug it and get a number and say, haha, I'm done. Okay? How many of you guys have gotten the antiderivative, can I show it off to the side, to be x cubed minus x? I'm close. What's wrong? X cubed? 1/3 x cubed. Good. So you guys can always double check by deriving. True. So 1/3 x cubed minus x. So I'm going to start plugging and chugging. So I have f of b 1/3 -1 cubed minus -1. That's f of b minus f of a for the first one. That'd be 1/3 -3 cubed minus a -3 plus 3. Double check my math, guys. Feel free to call out if you find a mistake. That's the first one. Plus 1/3 1 cubed minus 1. Supposed to be doing math and double checking these silly goofs. 1/3. Okay. -1 cubed minus a -1. That's f of b minus f of a, 1/3. Kiddos, a lot of you have been wanting numbers for a long time instead of variables. Now you got them. Please don't abuse them. Watch over them, take care of them, make sure they're all there. How's it looking? We're doing all right? I see negative 1/3 plus 1. That's 27 over 3 is 9, but negative 9 minus negative 9 would be plus 9 minus 3. Then I have 1/3 minus 1, negative 1/3 plus 1/3 minus 1, I think. And 3 cubed is 9, no, 27 over 3 is 9, 9 minus 3 minus 1/3 plus 1. Yeah. Did I miss something?
We'll start. Yeah, negative 1/3. Wouldn't it be 9 over 3 would be 3?
No, that's negative 1/3, right? Plus 1.
Okay, yeah.
Minus negative 9, which is plus 9, and then minus 3.
Oh, yeah, I see what you're saying. Okay.
Yeah, 1/3 minus 1. So that would be 10 minus 3 is 7. 7 minus a third, struggle. 7/3 is 21/3. Is that 20/3?
Yeah.
Which stays positive, so we're good. We have 1/3 plus 1/3 is 2/3 minus 2 minus 6/3 would be negative 4/3. Absolute value would be positive 4/3, I think. Then our last one. 9 minus 3 is 6. 6 plus 1 is 7. 7 minus a third would once again be 20/3. Is anybody double checking me with the calculator? I think my final hypothesis would be 44/3. Which is 13 and 2/3? 13.666.
14.666.
Oh, 14, thank you. 14.666. Make sure you have an absolute value.
Go calculator. I got 14.6.
14.66666. Dun 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 dun. Dun dun. Now, kiddos, we did figure out absolute value. Motion.
Yay!
We're gonna go back to motion just for a little bit. But then we do have 2 more things after motion. Motion won't take long. That's for, actually, we have a little bit of time. Cool. Hold on. Let's not do motion because we'll do that tomorrow. Let's actually go here. We can do this. We'll go here. We can do this in 2 minutes. Motion, we have to have you guys get your packets. So guys, tomorrow at the beginning, tomorrow at the beginning of class, have your motion packets ready and your notes. Motion packets and notes. So we can have ready tomorrow. Good. Average value. She's multitasking. Average value.
No.
Forever number 39. Remember I said that our forever quiz will be 30 to 40. Another reason why it's on Monday and not on Friday. Woo. Forever number 39. The AP loves to test on this formula. Loves it, but they kind of hide it, so it's kind of hard to see. Here's the craziness of the average value, guys. It depends on how it's worded, because we've already had something with average in it, and it was average rate. Average rate, we would do f of b, which in this case is position, f of b minus f of a, so x of 5 minus x of 0, all over 5 minus 0. Because we want the average rate of the person that we have. Average rate, we have to somehow get from miles per hour, we have to, by hand, do f of b minus f of a all over b minus a. That's average rate. That's old school. This is different. This is average value. What on earth is the difference between average rate and average value? Average rate says you need to derive, and since they're telling us average, we're not deriving, we're actually doing a rate by hand. Displacement over time, my physics people, right?
Yeah.
But if they ask for average velocity, And if we're given velocity, if they're asking for average velocity and we're given velocity, we're not doing anything by hand in the sense of taking a rate because they already gave us a rate. What we're doing is the average value of who we already have. The average value of who we already have. I'll try to explain that a little bit more tomorrow. It's kind of, well, it's actually really, I think, one of the most complicated concepts of CalcAB as to why it is what it is. But if we can just figure out when to use it, we'll be fine. Average rate says I need the rate of somebody. I need to still do something by hand in the sense of FB minus FL, say. Average value says you already have it, but now you need to average it. Okay, guys, that's it. Thanks for the extra 29 seconds we have here. Chapel day, our last day of spiritual emphasis. Pray it'll be a blessing, and I'll see you guys later. Lunchtime only. I'm only here at lunchtime if you need something. Otherwise, catch me tomorrow.